The law of cosines, again, works for oblique triangles, given patterns of SSS and SAS as far as the information that's provided. And what the law of cosine states is in any triangle with sides opposite the angles, you can make the statement that c squared, this one side squared, is equal to the sum of the squares of the other two sides. What is this right here? So it's based off the Pythagorean theorem with a slight adjustment. And the adjustment is you're going to subtract twice the product of those other two sides times the cosine of the angle opposite this original side. Okay, now here's the key to law of cosines. Whether you're SSS or SAS, one of these is the unknown. Okay, whatever's on the extremes, the outer, the beginning and the end, the very last first piece of information and last piece of information, one of those is the unknown, and then the other is the piece of information opposite the unknown. Okay, so if you're given three sides, the unknown is going to be your angle. Okay, so if you're given SSS, the unknown is going to be angle C, but you'll start with the side opposite that unknown angle. If you're given SAS, then your unknown is the side. It's the missing side, right? You'll have two sides and one missing side. So your unknown will be the side, and then capital C will be whatever information is opposite that unknown side. Okay, so let's take a look at an example of each of these. Okay. Now, actually, before I move on to the next screen, let me talk, because you don't know which side or which angle is your unknown, there really are three kind of versions of this law of cosines. If A was our unknown, we could set it up as A squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle opposite A. So this is an alternate form of the law of cosines. The relationships are still the same. And then if B or angle B was our unknown, we might have the form B squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle opposite B. So this would be a possible law of cosines as well. And it might be that you're given values of x, y, and z instead of a, b, and c. So does everybody see how these can change? The relationship, though, is the first and the last piece of information, one's your unknown, the other's whatever piece of information is opposite that, and then the a and b stuff on the inside is just the other information. It's the other given information. Okay, so let's take a look at SAS. Okay, Brian, give me a length that we can use for a side, please. Okay. And Matthias, give me another one, please. Okay. And Maddie, give me an angle measure, please. Okay. All right, so let's say we're taking this piece of information and we want to solve for the other unknown pieces of information, angle B and angle C, and side B. Okay. Since our pattern is SAS, this tells us that we are going to be using the law of cosines. Okay. And so in this case, what is our unknown? Side what? We're going to find side A. Again, you can call it X if you want. You can give it any name that you want. But let's say we call it A. So when we set up the law of cosines, we set it up as A squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides, all times the cosine of the angle opposite this side A. And so this winds up being a real easy calculation because it fits perfectly into the solve feature All you have to do is type the equation as it is. Our unknown is a side. The calculator will solve this by square rooting both sides. It'll do all those calculations for you. So we can simply type this in. So to solve, I'm going to replace a with an x just to make it easier to type in. But x squared is equal to 6 squared plus 11 squared minus 2 times 6 times 11 times the cosine of 23. And I'm going to put a decimal in here so that my answer is given as a decimal as well. Tell the calculator what you want it to solve for. Because I use my unknown as an x, I want it to solve for x, so comma x. And now when I hit enter, my answer gives me two values, a positive and a negative. Do we even need to consider the negative value that's yielded here when we extract the square root? No, because we're dealing with the length. And so we're looking at 5.96 approximately for our length.